Okay, now we're going to start tying some of these lessons together. And we've talked about the remainder theorem now, to where if you divide synthetically by x minus c, then the remainder is going to be the same thing as the function evaluated. We talked about factoring, how to factor with synthetic division. Now we're going to throw in the factor theorem. And here's what the factor theorem says. Given a polynomial function, and we'll call that function f of x. X minus c is a factor of f of x if and only if, which means this is the only way it could be a factor. If and only if f of c is equal to 0. So now we can use synthetic division, and again, some of you have already pieced this together. We can use synthetic division, and if we come out with a remainder of 0, which is, again, f of c equals 0 is the same thing as saying the remainder is going to be 0. Or we could even do this. We could actually plug the number in. X plus 1 is a factor only if I plug in -1 and I get 0, because that would force y to be 0, which would make it a factor. So let's use synthetic division. And it says use the factor theorem along with that synthetic division to determine which binomials are factors of the given function. Check all that apply. So let's see if x plus 1 is a factor. And the way that we're going to see if it's a factor is we're going to plug in -1. Because x minus c is a factor if and only if f of c is 0. So let's plug in -1 to 1x to the third plus 0x squared minus 31x plus 30. And let's see what we get. Bring down 1, multiply, combine them, multiply. -30 gives me a positive 30, which gives me a 60. So therefore, that means, according to your remainder theorem, f of 1 is -1 is 60. So that is not a factor. Let's see if x minus 5 is a factor. So 1, 0, -31, and 30. Bring it down, multiply, combine them, multiply. -6 gives me -30, 0 remainder. So that means that x minus 5, yes, is a factor because f of 5 is 0. Now let's try -6. Let's see if -6 or x plus 6 is a factor. 1, 0, -31, and 30. Bring it down, -6, combine. Gives me 36. 36 and -1 or minus 31 is 5, -30 and 0. So therefore, f of -6 is 0. And again, the factor theorem says that c, x minus c is a factor if and only if f of c is equal to 0. So therefore, x plus 6 would also be a factor. The second one, let's check x minus 2 to see if it's a factor. So let's plug in 2. But we're finding f of 2 here, 1, -6, -17, 78, -56, and 0. So that's going to take a little bit of room. Bring it down, multiply, add, multiply, add, multiply, 28, multiply gives you 56, 0, 0, 0. So therefore, yes, x minus 2, since f of 2 is equal to 0, right there. If you plug in 2, and you can check it, plug in 2 in all these places, you're going to get 0. Since f of 2 is equal to 0, then x minus 2 is a factor. Now let's try -7. So we're going to see if x plus 7 is a factor. Same numbers here, 1, -6, -17, 78, -56, and 0. 1, -7, add, multiply. 91 minus 17 is a 74. Multiply. Gives you -308. That's going to be -230. Multiply. And let's go back. I actually mismultiplied right here. Let's try that again. 74 times -7 would actually be a negative. That'd be 490 and 28. That'd be -518, which gives you a -440. Now multiply. And that's going to be 3,080. So we're getting into some big numbers now. I don't think this is going to be a factor. That's going to be 3,024 when you multiply that by -7. It'll actually give you -21,168, and I would dare say that that is definitely Not a factor, no. So I'm going to mark that one out. And lastly, let's try -4 and see if it's a factor. 1, -6, -17, -7, or +78, -56, and 0. Bring it down, multiply, that'd be -10, 40, 23, -92, -14, 56, 0, 0, 0. So therefore, -4, yes. F of -4 is 0, so therefore x plus 4 is a factor. Number 3 says, use the factor theorem and the given binomial to completely factor the polynomial function, then give the zeros. We've actually already done this once. I am going to eventually talk about some shortcuts that you can use here. We could have actually used on those last ones, but we're going to do these the same way. Given that x plus 3 is a factor, that means that when I plug in -3, when I find f of -3, which is what I'm doing here, I should get 0 as a remainder. So 1, 3, -4, -12, which I noticed something there. That's actually factorable by grouping, which is another way you could have factored this. 1, -3, 0, 0, -4, +12, which gives you a remainder of 0. So division by x plus 3 gave me this, constant x squared, so that is x squared minus 4. So we've just broken that down into, when we divided it, we got x squared minus 4, so we now have x plus 3 times x squared minus 4. And I can't stress that enough, that once you divide by this, and you get this, then you have broken this into x plus 3 times x squared minus 4. That will factor a little bit further, bring down x plus 3. This is difference of squares, which factors into conjugates. X times itself gives you x squared. 2 times itself gives you -4. Now given the zeros, those are the factors, linear factors, so your zeros are -3, -2, and +2. Same thing, x minus 5 is a factor, so let's synthetically divide by 5. We've got 1, -2, -19, and 20. Dividing that, bring it down, multiply, add, multiply, -4, -20, 0 remainder. So we've now broken that down into x minus 5 times this constant x squared. So x squared plus 3x minus 4. So break it down again, bring down the x minus 5, adds, multiplies will be a +4 and a -1. So my zeros are 5, -4, and +1. These are my factors. These are my zeros. Division by 7, it says x minus 7 is a factor. So we have 2, -7, -53, and 28. And we are using the factor theorem. And there's another way we could have done the factor theorem. If you wanted to, you could have actually plugged a 7 in for all these. When you plug in a 7, you're going to get 0. But it's much easier to use synthetic division, because then we can actually use that to break it down. So 2, 14, 7, 49, -4, -28. So you have broken it down into x minus 7 times 2x squared plus 7x minus 4. We're going to have to use slip and slide. That'll be x squared plus 7x minus 28. That'll be x and x. Or excuse me, that'll be, yeah, that's right. Or minus 8, excuse me. That'll be a +8 and a -1. Divide by the number you slipped. That'll be x plus 4, and that will not reduce, so 2x minus 1. So you now have x minus 7, x plus 4, and 2x minus 1 are the factors. So your roots are 7, -4, and 1/2. Okay, number 6, another one. X plus 2 is the factor, so let's divide by -2. So again, what we're doing here, f of -2 would be 0, and you could plug in -2 for all the x's, and you would find out that f of -2 is 0, which means that x plus 2 would have to be a factor. Again, the better way of doing that, instead of plugging it in, is by using synthetic division to plug it in, because then we can use it to break down this polynomial function. So 9, -18, -36. A lot of people there would be tempted to put 0. 72, -1, +2. 2 and 2 is 4, negative 8, and it does give you the 0. Now you're left with 4 terms though, and this one's different. So we now have, we broke it into x plus 2 by dividing, times constant x squared, x to the third. So that'd be 9x to the third minus 36x to the second minus x plus 4. And the only method we have right now of factoring, if it has 4 terms, is by factoring by grouping. So now I have x plus 2. I'm going to put some brackets because I'm going to factor the 9x squared out of that. And then I'm going to use parentheses. You're left with x minus 4. I'm going to factor a negative 1 out of the second group, and you're left with an x minus 4. The two groups both have an x minus 4, so now we can get rid of those brackets. We're going to factor the x minus 4 out of both groups. You're left with a 9x squared and a minus 1, which is now difference of squares. Okay, so we now have x plus 2 times x minus 4. 9x squared minus 1 is difference of squares, factors into conjugates. 3x times itself gives you 9x squared, positive 1, negative 1. Gives you the minus 1. So that's my factors. So my zeros are negative 2, 4, negative 1/3, and positive 1/3. And we're done. Number 7, x plus 5 is a factor. So let's find f of negative 5 by plugging it in there. 3, 5, negative 42, 40, and 0. If you wanted to, you could actually have factored out an x before you even started. Either way. So you now have, bring it down, that's negative 15, negative 10, 50, 8, negative 40, 0, 0, 0. Which gives you, we divided by x plus 5. And we got constant x squared, x to the third. So 3x to the third minus 10x squared plus 8x. All three of those terms have an x, so I'm going to factor that x out next, and I'm going to write it completely out front. The reason that is legal, multiplication is commutative. It does not matter where you put that, in front of or behind, it's still multiplication. 3x squared minus 10x plus 8. That's going to be slip and slide. So that's going to be x squared minus 10x plus 24, which factors into add, multiply, negative 6 and a negative 4. We slipped the 3, so let's divide by 3. That'll be x minus 2 times, slide it back up front, 3x minus 4. So now my final answer, x times x plus 5 times x minus 2 times 3x minus 4 is the factored form. So my zeros are, set them each equal to 0 and solve it. X equals 0, negative 5, 2, and 4/3. And the last one, 3 is a root, which means f of 3 is 0. So let's try 3. Let's see, we're going to do 4, negative 12, negative 13, 39, 9, and negative 27. That's a long problem. Bring down the 4. You get 12, negative 12 and 12 is 0, 0, negative 13, negative 39, 0, 0, 9, 27, 0. So my remainder is 0. So I divided by x minus 3. And I got, let's see, constant x squared, x to the third, x to the fourth. 4x to the fourth minus 13x to the second, and a positive 9. This is not quadratic, but it is quadratic form because you have x to the fourth, x to the second, x to the 0. So let's use slip and slide on that. Gives you x to the fourth minus 13x to the second, and a positive 36. Two sets of parentheses would be an x squared and an x squared, negative 9, negative 4. You slip the 4, so now let's divide by it. And you will have, let's go ahead and bring my x minus 3 down. Two sets of parentheses. X minus 9/4 will not reduce, so move the 9 back up front. It'll be 4x squared minus 9. And then x squared minus 4 over 4 will be x squared minus 1. And both of those are difference of squares. So I now have x minus 3. Difference of squares factors into conjugates. Plus, minus. 2x times itself gives you 4x squared. 3 times itself gives you 9. X squared minus 1 is also difference of squares, which factors into conjugates. X times itself gives you x squared. 1 times itself gives you 1. And it's a good thing that was quadratic form, because that's the only way that right now that we know to factor for x or any x to the fourth stuff. So those are my factors. So my roots, set each of those equal to 0 and solve them. My roots are going to be 3, negative 3 halves, and a positive 3 halves, a negative 1, and a positive 1. So this function is going to look something like this. Would actually cross the x-axis 1, 2, 3, 4, 5 different times.